So today we're going to be taking a look at what's called scientific notation. Scientific notation is a special way of writing numbers, typically that are really big or that are really small. It's used in the scientific community. If you think about talking about distances, the planets and things like that, you're talking about really big numbers, or if you're talking about sizes of really small things, atoms, molecules, things like that, really small numbers. So I came up with a system of writing some of those numbers in a little bit easier to use format. Okay, so let's start with a large number. I'll just make a number up here. Let's say we have the number 63 trillion. So there's million, billion, trillion, right? So it's a lot of zeros you have to write. So your day could be spent with writing zeros if you have to work with those numbers. So scientific notation is a way to shorten that. Okay, it basically contains three parts. All right, so the first part we find by simply, we're going to start at the left side of the number, and we're going to put a decimal after the first number that's not 0. In this case, that's 6. Okay, and then we're going to truncate it. We're going to chop it off when there's only zeros left. So at this point, all I have left is zeros in my number. Okay, so my first number is going to be 6.3. Okay. Now, that first number is always going to be at least 1. If we think about putting a decimal point after a number, right, it's got to be at least 1, right, at a minimum. Okay? And if it's after one digit, it has to be less than 10. All right, so your first number is always going to fall in that range. Okay? So that's the first part. We write that number. And then it's always a times 10, right? Always put that. Now, if we think mathematically, what happens when we multiply by 10? Well, it moves a decimal point one spot to the right. So if I go back to my original number, right, if I multiply by 10 once, it's going to put it here. So I'm basically want to figure out how many times do I have to multiply by 10 to get it back to the end. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we're going to make that our exponent. I've got to multiply by 10 13 times to get it back to its original spot. Okay, so this is 63 trillion in scientific notation. Okay, let's do one more of those. All right, 605 million. All right, not a really big number, but enough zeros to where we might want to rewrite it. So again, put our decimal point after the first non-zero number. So right after that 6, and we're going to cut it off when only zeros are left. Okay, so I'm not cutting it off after the first 0 because I have a 5 after it. So my first number is 6.05. Okay. Again, it's at least 1. It's less than 10. Times 10. Now, we're not counting zeros. I repeat, we're not counting zeros. The most common error on this is students counting zeros. It's decimal place movements. Okay, our exponent is not going to be 6 because there's 6 zeros left. Okay, when we multiply by 10, we move the decimal point. So basically, I'm asking myself, how many times do I have to move that decimal point to get it back to the end? Well, that's 1, 2, 3, 4, 5, 6, 7, 8 places. So that becomes our exponent, 6.05 times 10 to the 8th. Okay. Now, we can do the same thing with really small numbers. Say we had something like this. I don't know, what is that number? That's 45, tens, hundreds, thousands, 10,000s, 100,000s, millions, 4,500 millionths, right? Really small number to work with, okay? The process is going to be the same. So we'll go left to right, put our decimal point after the first non-zero number, okay? So my first part is 4.5. Again, it's got to be at least 1, less than 10, times 10, okay? Now, let's count our decimal movements. 1, 2, 3, 4, 5, 6, 7. Now, the difference here is we're moving left, right? We're getting smaller. We're multiplying not by 10, but by a tenth. Okay? So we learned with our exponent rules that a tenth is like 10 to the negative first power. So since we moved 1, 2, 3, 4, 5, 6, 7 places to the left, okay, we make our exponent negative. Right? So that number would be equal to 4.5 times 10 to the negative 7th power. Let's do one more. Okay, again, decimal point after first non-zero number, right there. Right, we're going to cut it off when only zeros there. So 4.12 is our first number. Again, at least one less than 10. Times 10, and our decimal point moves 1, 2, 3, 4, 5 to the left. Okay? Do not, I repeat, do not count zeros. I don't even know if I spelled zeros right, but do not count zeros. Okay? It's decimal place movements. Do not count zeros. That will mess it up. Do not count zeros. We're counting decimal place movements. In case you missed it, do not count zeros. We're counting decimal place movements. For those of you in the back, do not count zeros. We're counting decimal place movements. Okay, so that is taking numbers in standard form and rewriting them as scientific notation. Now, I'll also ask you to do the opposite. So I might give you a number in scientific notation and ask you to rewrite it in standard form. Okay, so the regular number form that we're used to. Okay, so pretty simple. All we have to do is look at our exponent that tells us how many times to move our decimal point. We do not, say it with me, we do not add zeros. We're moving decimal points. So this says move your decimal point. It's positive, so right 5 places. Okay, so I move it after the 5. That's 1 place. Then I have to add 4 more zeros. 2, 3, 4, 5. And then rewrite it. Don't write your number like that. That looks messy. Okay, rewrite your number. Put your commas in the right spots. 450,000. Okay, let's do one more. 3.2 times 10 to the negative third. Okay, again, start out with your first number. Negative 3 means we're moving left 3. So 1, add a couple zeros, 2, 3. 0.0032. Please rewrite your number. Don't leave it like that, right? That's not how we write numbers. So rewrite your number so it looks nice. All right. Again, we're not adding zeros. We don't go, I add 5 zeros. I add 3 zeros to the left. It's number of decimal place movements. All right.